So let me dig in a little bit more on this idea of convergence. So again, this is the technical definition for the convergence of a sequence. And this is very much like the definition for convergence of a function as x goes to infinity, or as x goes to some finite number, say a. But here, our variable is just telling us which entry of the sequence are we at. So we can write this using the limit notation, the limit of the sequence an as n goes to infinity equals L. Or we can do this with the arrow notation instead. A of n tends to L as n tends to infinity. And what these mean is that for every epsilon positive, then at some point the sequence will always be epsilon close to the limiting value L. Okay, well that's a bit technical. Let's take a look at this on Desmos, and here I have hidden the y-axis because I won't be using it. Think of this as just a scatter plot of my sequence. So what sequence do I want? I'll take the sequence where the first term is 1/2. So let me plot x equals 1/2, and I get this I get this vertical line here, make it a little bit easier to see. So this is going to be somewhere between, well, be exactly between 0 and 1, of course. And now for later terms of the sequence, I'm going to plot, well, my second term of the sequence I'm choosing will be x equals 1/4. There it is, represented by this vertical blue line. My third term of the sequence I'll represent by x equals 1/8, and so on. And what's going on is that each term of the sequence is half of the term that came before it. So if I was going to write this as a formula, right, it would just be 1 divided by 2 to the power n. N is the index, right? So the nth number on my list would just be 1/2 to the power n. There's actually kind of a neat way I can do this in Desmos. I'll say n equals 1, 2, 3, 4, 5, 6, 7, 8, and so on. Now, unfortunately, Desmos can only handle finitely many numbers at a time. And I'll ask it to plot, show me x equals 1 divided by 2 to the power n. So there are all of the values I've asked for. Now, something to notice here is that since I'm zoomed out this far, eventually I can't actually tell these sequence values apart. They are so close together, then, well, the pixels are just overlapping and they might as well be the same. Now, granted, I can zoom in a little bit more, but I get a similar picture. So again, this is my first value of the sequence, 1/2, the second value of the sequence, 1/4, the third value of the sequence, an 1/8, and so on. And even at this level of zoom, now I can tell some of these apart better where they looked like the same number from far away. But the later elements of my sequence are still getting closer to 0. So here's a graphical representation of that limiting process. No matter how far I zoom in, maybe some of the sequence values have disappeared off the right side of the screen, but no matter how far I zoom in, I still have this clustering around, well, x equals 0, because that is the limit of this sequence. So as n tends to infinity, this sequence, 1 over 2 to the power n, will tend to 0.